Yeah, hello everyone, and thank you for nice introduction. Personally, I'm feeling a bit not in my plane because I'm not really going to talk much about the development of MicroLED technology. But I'm going to talk how we are going to use the MicroLED technology to develop a new augmented reality gadget. We are a company called XPANCEO, and we are developing strange thing. We are developing smart contact lens. My name is Valentyn. By the first and main education, I am a scientist, and my main activity until recent time was connected to the creation of scientific papers. But a few years ago, I was involved in a strange adventure. So basically, together with my partner, we launched a company. And now we are trying to develop a very strange gadget. So here you can see some evolution of computers that happened for the last years. Basically, it shows this scale where the computer changed from mainframe devices to smartphones. At each step, computers became more and more, let's say, private and wearable. So the question, what would be the next, of course, and the answer, obviously, especially after all the noise that was created like yesterday about all this Orion project, obviously it's an augmented reality gadget. And helmets and glasses already here, and seems that sooner or later we will have this technological jump and we will get glasses that are really nice, slim, and very efficient in terms of power consumption. But we actually, and this gadget would be probably the gadget of tomorrow. What we are doing, it's probably a gadget of the, I don't know, next week or maybe next month, hopefully. So we are trying to develop the idea of smart contact lens. It's like when I say some contact lens, it's like a real contact lens. Like we actually working both with soft materials, I mean soft polymer matrices, soft polymers and rigid ones. So they are weightless. They are almost as natural as your own vision. That's the ultimate wearable gadget, the only one. The next one would be probably if you take all the electronics and integrate it directly on your inside your eye. So here you can see a schematical representation of our gadget. I know it looks kind of strange. It consists, accumulate, let's say, things from our background of different areas. So it has a display at the very center. I will talk a bit later about our displays research. Then we have antennas, we have transparent and flexible electronics integrated, some biosensors, plus neural interfaces. I know it sounds strange, but you know, from optogenetic point of view, our eye, especially retina, it's a part of the brain. And now Elon, he's trying to make holes into the skull. Basically, we are trying to do the same, taking a signal directly from the eye. It's actually, it works. It's especially if you are not trying to directly connect, kind of to let's read your brain from the eye, but kind of do it in the intermediate state. For example, like try to read muscular activities, for example, by your fingers or tongue, then you can really nicely see it from the electrodes integrated, jet electrodes integrated onto the lens. I'm not talking today about this today, but that's really interesting thing. Then, of course, antenna, we have a bunch of batteries, also solar cells for self-feeding. Yeah, and then all in all, as we say in our company, the best devices is no device. Would be, of course, nice to have something which is maximally comfortable and give you ability to interact with surrounding world without actually even feeling of the device that you wear on you. Again, so it's supposed to be maximally weightless, invisible. It will good, I mean, again,